Hello, this is section 3.3 on polynomial and synthetic division. We've been talking about polynomials, and now we're going to talk about dividing them so that we can break them apart, find their zeros, and things like that. So first, let's talk about division in general. What happens with just numbers? If I ask you, what's 42 divided by 7? The answer would be 6. And in a way, I'm asking you, what do you have to multiply times 7 to get 42? So the answer is you have to multiply 7 times 6 to get 42. So 42 divided by 7 is 6. 7 times 6 equals 42. If I ask you what's 44 divided by 7, the answer is 6, but with a remainder of 2. There is no whole number that you can multiply by 7 and get exactly 44, but you can multiply 7 by 6 and get 42, and then add on 2 to get 44. So 7 goes into 44 6 times with a remainder of 2. The same sort of thing happens when you're working with polynomials. I could say, what is 3x cubed minus 30x squared plus 5x minus 50 divided by x minus 10? And the answer to that is 3x squared plus 5, because you'd have to multiply x minus 10 times 3x squared plus 5 to get 3x cubed minus 30x squared plus 5x minus 50. Try it if you don't believe me. And if I said, what's 3x cubed minus 30x squared plus 5x minus 30 divided by x minus 10, it's 3x squared plus 5, but with a remainder of 20. That is, you'd have to take x minus 10 times 3x squared plus 5, and then add on 20 to end up with 3x cubed minus 30x squared plus 5x minus 30. So some terminology here. The big polynomial that we start with, we call that the dividend. What we are dividing by is the divisor. The answer we get is the quotient, and then of course we have the remainder. So the dividend divided by the divisor is equal to the quotient with sometimes a remainder. So the dividend is equal to the divisor times the quotient plus the remainder. Sometimes the remainder is 0 if the division comes out even, and sometimes it's not, but it's always going to be lower degree than the divisor. So if we divide by a degree 1 polynomial, the remainder can only be degree 0, which means just a number, just a constant. So how do we actually do the division? How do we actually divide one polynomial by another and figure out what the quotient and the remainder are? One method is by long division. I'm not going to do that in this video, but you may have learned about that somewhere along the line. There are videos online that can show you how that works. There are examples in the textbook, but what we're going to be doing is a shortcut, easier way that doesn't work for all polynomial division, but it does work for the kinds that we're going to be doing, where you're dividing by just x minus some number. So as long as your divisor is just a first degree x minus something or x plus something, you can figure out the quotient and the remainder by synthetic division, and here's how this works. So here's our example. We're going to be dividing 3x cubed minus 2x squared plus x minus 8 by x minus 2. So I'm going to start by writing just the coefficients of all the terms of the dividend. So that's the 3 and the negative 2 and 1 and negative 8. And then out in front here, since I'm dividing by x minus 2, I'm just going to put the number 2. Not negative 2, but 2. That number out in front, that 2, that's going to be our multiplier. Okay, so to start with, I'm just going to take this 3 here and bring it down and write it down here below the line. And now my multiplier 2 times that 3 gives me 6. And I'm going to write the 6 right here. Now I'm going to add down in this column, the -2 plus the 6 adds up to 4. And now I'm going to multiply 2 times 4 to get 8. I'm going to put that here. Now I'm going to add 1 plus 8 is 9. And now I'm going to multiply 2 times 9 to get 18. And now I'm going to add -8 plus 18 equals 10. So notice I'm adding down the columns and I'm multiplying to get the numbers in this middle row here. Now that I've done all those calculations, here's what this tells me. This number on the end, this 10, that is the remainder. And these other numbers, the 3, the 4, and the 9, tell me the quotient. So the quotient is 3x squared plus 4x plus 9. And like I said, the remainder is 10. So in other words, if we took what we were dividing by, which was x minus 2, multiplied by the quotient, 3x squared plus 4x plus 9, and then added on the remainder of 10, that would get us back to the dividend that we started with, the 3x cubed minus 2x squared plus x minus 8. Okay, let's try another example. Divide x to the 4th plus 4x to the 3rd plus 2x squared plus 9x plus 4 by x plus 4. So the coefficients of this big polynomial are 1, 4, 2, 9, 4. And this time I'm dividing by x plus a number, x plus 4. So I'm going to put -4 out in front. So keep that in mind. When you're dividing by x plus a number, you put a negative number out in front. When you're dividing by x minus a number, you put a positive number out in front. Now we've got it set up, we're ready to start adding and multiplying. So bring down the 1, multiply -4 times 1, and we get -4. Add 4 plus -4 is 0. Multiply -4 times 0 is 0. Add 2 plus 0 is 2. Multiply -4 times 2 is -8. Add 9 plus -8 is 1. Multiply -4 times 1 is -4. And add 4 plus -4 is 0. So first of all, notice that the remainder we got this time was 0. The division came out even. And the quotient is given by these other numbers here. Since we started with a degree 4 polynomial, we always go down 1 when we're dividing by a degree 1 polynomial. So the quotient is a degree 3 polynomial. It's going to start with an x to the 3rd power term. So it's going to be 1x to the 3rd plus 0x squared plus 2x plus 1. So the division came out even. So that means if we took the x plus 4 times the x cubed plus 2x plus 1 and just multiplied that back out, we'd end up with x to the fourth plus 4x to the third plus 2x squared plus 9x plus 4. Okay, one more example. 3x cubed minus 4x plus 10 divided by x minus 1. So what numbers do we put here? 3, -4, 10. But wait a minute, that's not quite right. Can you see why? If we just put 3, -4, 10, the synthetic division is going to think we mean 3x squared minus 4x plus 10. We really mean 3x to the third power plus 0x squared plus -4x plus 10. So we do have to have a 0 there for the missing x squared term. And what number goes out in front? We're dividing by x minus 1, so we put just a 1, a good old positive 1 out in front. Now here we go, bring down the 3. 1 times 3 is 3. Add 0 plus 3 is 3. Multiply 1 times 3 is 3. Add -4 plus 3 is -1. Multiply 1 times -1 is -1. Add 10 plus -1 is 9. So the remainder is 9. And the quotient is given by the other 3 numbers in the bottom row. It's going to be a degree 2 polynomial. Specifically, it's going to be 3x squared minus 4x, or sorry, plus 3x minus 1. Now, I want to say something about this, but I don't want this video to get too long, so I'm going to save what's coming next for the next video. To be continued. We'll talk about the significance of this, and once we've done this synthetic division, what we've learned in the next video.